Assalamualaikum. This is our group assignment for the topic of mid-air collision over in Germany. Kill about 71 people. So our group members is Muhammad ILHAM NAFIS bin SABTIA RADHZI, Muhammad ASYRAF FAISAL bin KHABIR, and Muhammad ARIF bin Muhammad SALEH. For the question 1, identify the system used in the aircraft to reduce the risk of mid-air collision. Describe the version of the system and the system components. Identify the system used in the aircraft to reduce the risk of mid-air collision. So the system used in both aircraft is TCAS version 2. TCAS is a traffic collision avoidance system or traffic alert and collision avoidance system. The function is to reduce the incidence of mid-air collisions between the aircraft. Describe the version of the system and the system component. TCAS 2, for the TCAS 2, more comprehensive than TCAS 1. It is used in the majority of the commercial aircraft. Operate the same as TCAS 1, but has greater range and bearing accuracy than TCAS 1 and a resolution advisor RA function. In the event of the potential collision, TCAS 2 will issue a RA to each pilot that consists of direct, vocalized correction, or preventive vertical maneuvering command to avoid a collision. TCAS 2 system coordinate resolution advisories to maximize aircraft separation so that if one of the aircraft is instructed to climb, the other aircraft will be instructed to descend. This is example for TCAS 2. For the other TCAS version, first of all is passive. Passive is display traffic similar to TCAS but have a shorter range. Rely on transponder replies triggered by ground and airborne system that query nearby transponders for altitude information, monitored by third-party system for traffic information. For the TCAS 1, less expensive and less capable than TCAS 2 and TCAS 3. It is designed primarily for general aviation use. Display the approximate bearing and relative altitude of all transponder equipped aircraft within a range of approximately 40 miles. Generate collision warning via TA that warn the pilot of nearby aircraft. When the flight crew receive a TA, it is up to pilot in command to decide what action to take in response to the TA. The pilot may notify aircraft control for assistance in resolving the conflict. For the TCAS 3, TCAS 3 offers both vertical and horizontal RA and TA. Horizontal directive commanding left or right are beneficial for two conflict aircraft close to the ground with minimal vertical space. TCAS 4, due to the limited accuracy in using directional antenna for TCAS 3, TCAS 4 use information encoded by the aircraft in the mode as transponder reply. It will require reliable sources of position such as GPS in order for the aircraft to be encoded. This project is also being abandoned since the appearance of new trend of data link. For the TCAS system components, there are 4, which is first of all receiver or transmitter, top directional antenna, bottom omnidirectional antenna, and control panel. TCAS receiver transmitter is a typical black box assembly and is mounted in the aircraft electronic compartment. Has full built-in test equipment, which is byte capability in fault finding. This is example for the black box. And then antenna. Top directional antenna connected to the TCAS computer using 4 axial KHABIR. This is 4 element vertically polarized monopole array that is capable of transmitting interrogation in 4 selectable direction of 1030 MHz. The antenna capable of receiving reply at 1090 MHz from all directions at the same time. This is example for the antenna.
Okay, for the question 2 is a review on the principal operation of the system. So the operation is the TCAS standard uses the standard transponder, having the interrogator on board in addition to the transponder itself. The aircraft periodically broadcasts the interrogation signal. The power is less than from the ground radar, but sufficient to trigger response from aircraft that may be less than a minute of flight. The distance to the aircraft is determined from the timing the signal. Closure rate from the 2 consecutive measurements of a distance and pressure altitude is a part of the transponder response. Position can only be determined approximately by using directional antenna, so it is only used for showing the other aircraft on the navigation display, but not for the determine the resolution. The system activates if the closure rate is such that collision could possibly happen in some specific time. That does not mean that aircraft are actually on colliding courses. The TCAS system does not evaluate heading or positions. It is just that the momentary closure rate is high enough. If the aircraft could collide in 40 seconds, the system gives out a traffic advisory. This is just a warning that there is a nearby traffic and that an action may need to be taken soon. If the distance reduced so that the risk of a collision gets to 25 seconds, a resolution advisory will be given. This is an instructions to climb, descend faster or level out. The pilot is required to comply in 6 seconds. The instructions have priority over ATC instructions. So this is a TCAS block diagram operations. And then the third question is the interpret the information displayed in the cockpit that involved in the system. So this is the TCAS display. It have RA, area in 2 nm, vertical speed, pointer, necessary vertical speed, other aircraft, relative altitude, vertical speed trend, and the aircraft positions. The TCAS operation. So that's all from me. This is TCAS calculates the bearing, range, trajectory, and speeds, relative altitude.
Okay, hi. For the next question, number 4 is evaluate the cause of accident and suggest the solution to increase the safety and awareness of the risk aircraft collision. Cause of accident. The integration of ACAS or TCAS2 into the system aviation was insufficient and did not correspond in all points and with the system physiology. The regulations concerning ACAS or TCAS published by ICAO, and as a result, the regulation of National Aviation Authority's operational and procedural instruction of the TCAS manufacturer and operator were not standardized, incomplete, and partially contradictory. Management and quality assurance of the Air Navigation Service Company did not ensure that during the night all open workstations were continuously staffed by controller. Management and quality assurance of the Air Navigation Service Company tolerate for years that during times of low traffic flow at night only one controller worked and the other one retired to rest. Next is solution to increase the safety and awareness. Okay, number one is check yourself. Start with a check of your own condition, your eyesight, and consequently for your safety, and depend on your mental and physical condition. Plan ahead. Plan your flight ahead of time. Have a chart folded in a proper sequence with a handy reach. Keep your cockpit free of clutter. Be familiar with headings, frequencies, distance, etc. and ahead of time, so that you spend minimum time with your head down in your chart. Some pilots even jot these things down on a flight log before takeoff. Check your maps and the special general and area notice in aircraft maintenance manual in advance for restricted areas, oil burners route, intensive student jet training areas, and others high density spots. Okay, number 4 is during clean windows. During the walk around, make sure your windshield is clean. If possible, keep all windows clear of obstruction like solid sun, visor, and curtains. Number 5 is adhere to standard operating procedure. To stick to standard operating procedure and observe the regulation of flight, such as correction altitude and proper pattern practice. You can get into big trouble, for instance, by sneaking out of your proper altitude as cumulus cloud begin to tower higher and higher below you, or by skimming along the tops of clouds without observing proper separation. Some typical situations involving in-flight mishaps around airports include entering a right-hand pattern at an airport with left-hand traffic, or entering downwind so far ahead of the traffic pattern that you may interfere with traffic taking off and heading out in your direction. In most in-flight collisions, at least one of the pilots involved was not where he was supposed to be. Okay, next is avoid crowds. Avoid crowded airspace and routes, such as directly over a VOR. You can navigate on VFR days just as accurate by passing slightly to the left or right VOR station. Pass over airport at safe altitude, being particularly careful within 25-mile radius of military airports and busy civil field. Military airports usually have very concentrated of fast-moving jet traffic in vicinity and pattern that extend to 2,500 feet above the surface. Okay, next is compensate for design. Compensate for your aircraft design limitation. All planes have blind spot. Now know where they are in your aircraft. Okay, next is equip for safety. Your airplane can in fact help avoid collision. Certain equipment that was once priced way above the light plane owner reach now is available at reasonable cost at all aviation segments. High intensity strobe light increase your contrast by as much as 10 times day or night, can be installed for about 200 each. In area of high density, use your strobe or your rotating beacon constantly, even during daylight hours. The cost is pennies per hour. Small price to pay for making your aircraft easier for other pilots to see. Transponder available in quick installation for Kit 400-4000. Significant increase your safety by allowing radar controller to keep your traffic away from you and vice versa. Okay, that's all from us. Thank you.